Captain Peter Cutsey. We're downwind on vectors for an ADF, a beacon approach, that is a 2 NDB Yankee approach to runway 09 at DUSHANBE, Tajikistan. The reason I picked this airport to demonstrate a circling to land is there are no precision approaches to runway 27. This is a single runway airport. The precision approaches are from the west to the east on runway 09. When the winds are such that a landing on 09 is not advisable, and the requirement is to land on runway 27, then all you have available to you at this airport is 2 non-precision approaches and their beacon approaches. So this airport is an airport that definitely needs or requires a circle to land procedure. And as I've mentioned on my website, if you have a look at it, we don't want pilots typing in their own coordinates. These circling to land procedures should be line selectable from the database. And what we're demonstrating here is we are in an FAA approved simulator, and we'll show you the procedure that we, latlongglobal.com, can design for you and insert into an offsite database where you can use it for free for 3 months. No charge. I provide the information required to train pilots. I'm a consultant, and I've started these particular procedures in 1985. That is, started designing for line selectable from the database. We haven't been using the FMS to its full extent, and these are done under visual conditions. So we're going to use a minimum. If you've noticed here on the chart, we're going to use a minimum of 4,040, which is 1,465 feet above the airport elevation. And you should have a good view of the airport for these approaches. So in this particular case, we're going to use that minimum, and we will actually let you have a look at it here. We've set it already in the aircraft, as you can see here. So 4040. And we haven't temperature corrected the altitude today, because at the airport today, the temperature for this demonstration is standard, and the standard for this airport, ISA, is 10 degrees. And we're also using a standard QNH. Remember, at this airport, the transition altitude is 8480, and the transition level is flight level 100. I've frozen the simulator just so that we can have a look at the terrain. As you can see from our position here, this is a real-time map on the approach plate. That's us right here. So we are heading 266 degrees. The wind is calm for the sake of this demonstration, and also the weather is clear, so that the pilots who are being trained would have a good look at the terrain in the simulator, whereas when the weather is at minimums, they would not be able to appreciate the reason why the importance to be using the VSD, radio altimeter, and barrel altimeter, 3 that we'll be using throughout, and pilots should be trained to use those 3 throughout a circling to land maneuver. The we'll let you have a closer look at the chart. Here it is here. And we are executing a NDB Yankee to runway 09 with a breakoff point at the minimum for circling. Well, there isn't a circling minima on the chart, and circling minima is not banned at this airport. So therefore, a carrier, an air carrier could, if they had the circling to land installed in their database, and that's what we do at Lat Long Global, and we're going to demonstrate it today, and you can see what we do. Then you could go ahead and use the minimum because it's high enough at 1465 for what I personally recommend. Air carriers will set their own limits for circling to land. The higher, the better, so that the pilots have a view of the terrain around. So here we are here, and we'll just go back to the simulator and put us dynamic again. And we are in these maneuvers. We're at flap one, we're at 2,220 feet above terrain, and here's our VSD. So the barometric setting is correct. And incidentally, at this airport, the because it's in a part of the world that they do use meters, you have that capability of selecting meters. But for this approach, we'll be definitely using and mandatory to use Q and H, and we're going to stay with the hectopascal reading. There is the terrain above, below the aircraft, and the indication of that terrain here is above sea level. So the terrain is quite high. At this point here, it is somewhere close to 3,000 feet above sea level. So that's why it's important to be using a combination of VSD and radio altimeter. In the turn now to base lag or on vectors for this demo, and we've selected flaps 5, and we've selected flaps 5 speed. We'll be executing this maneuver in VNAV and LNAV. And if you notice up on our PFD, we've captured the LNAV course, and we are in VNAV path. Very important that we observe that throughout. You can see the VSD with the terrain in front of us. The aircraft was a little slow at capturing, at turning. Anyhow, it is turning now, and this is what we're observing. And there's the terrain. Very important that you monitor that throughout. We have captured the final approach course, so we now should set our heading bug to the course itself. The 086. Okay, I've frozen the simulator so that we can actually have a better look at the two instruments we'll be using throughout this approach, our primary flight director and our nav display. Uh, the if you notice up on the top left corner, we are indicating an RNAV W27 265. No, that is actually the course of the runway track later. So it's runway 27 is what the landing runway is, and we're 23.7 nautical miles. Where the LNAV, VNAV will be armed for the missed approach. Now remember, if a missed approach is required, you carry out the missed approach for the IFR approach that you've executed. And we are executing a beacon approach, an NDB Yankee to runway 09. So this is the missed approach procedure. We've got the beacons tuned, and remember that you would always turn towards the airport to execute the missed approach for the approach. As far as airlines are concerned, your nav database provider, in conjunction with our company, would ensure that the tailored maneuver includes the missed approach procedure for the NDB Yankee to runway 09. That's very important. All right. So if you notice here on the nav display, we have a 2 nautical mile ring as a reminder to start doing things. But we happen to be at 6,000 feet, and top of descent is actually before that. So in this particular case, because of terrain, 2 nautical miles prior to top of descent, we will start configuring. And we have different items, 8 items to make sure that we're in VNAV path, to set the minimum on the MDA, on the MCP, and to make sure that we are RMP, AMP is within limits, and it is. Then gear down, flaps 15, speed brakes arm, and set flaps 15 speed. We will not set the go around or the missed approach altitude yet, because this is a very different procedure. We have to make sure we stay in VNAV path. So for a minimum, when we actually set the minimum, we'll set just 100 feet above the threshold. And the threshold at this airport is 2575. So 2675, let's say 2,700 feet for a minimum is what we'll set. And we'll be monitoring VNAV path throughout. We may have to make a small adjustment if the vertical path changes to VNAV alt. We will have to make a change in what we said on the MDA. Now let's see what happens on this maneuver. And you may notice as we get closer, and we'll talk about it, you'll see several waypoints in the arc transitioning from downwind to the final approach fix, which we've identified as Delta Uniform 27 Alpha. That's because this simulator software doesn't do what the aircraft software does. So that is, we can't generate a radius to fix arc. So I had to create 5 extra waypoints on that arc, and we have the capability of doing that in our company. So in order for us to actually fly and put us in the position we want to be. So I thought I'd mention that now. All right. Coming up to our about 2 nautical miles from top of descent. You're down flaps 15. Speed brakes armed, and we'll set flap 15 speed. And we did have VNAV path, and we did have RMP EMP within the requirements before we did that. Here's the top of descent on the screen. You can see it. We perhaps initiated it a little soon. Oh, we want flaps at 15. And we'll set flaps 15 speed. We have all the tools we need on the in this maneuver. The VSD, as you can see here, and our profile, we're just about 1,000 feet below the top of descent, and we'll make sure that the aircraft does start down at that point. Now we've gone into an altitude hold because we didn't set the, so we'll just quickly do this and go back to VNAV, and then we're back in VNAV path. We should be, and we are. And that's what you would do if you forgot to set it. Now we'll set the minimum to what we said at 2,600 feet. And we are in VNAV path. You can disregard the text. It's not reading my voice correctly. There are words there that have come up. So we've started our descent. We're slightly high in the descent. So the rate of descent is a little high for the time being until we regain our path. That's because we didn't set the MDA when we should have. Here's our path here, and we're flight following it. Okay, and now radio altimeter alive. So we're coming back to path, back to speed. And our minimum is 4,040. No corrections today because the temperature is standard. We're coming up to the breakoff point. We're at 1,680 feet. And there is our aircraft, and there is our VSD. Safe. The descent procedure and approach procedures and associated checklist has been complete. This breakoff point is very carefully calculated by our company to ensure that we will be within the confines of the ICAO requirements for circuit to land. Approaching minimums. So approaching minimums, we're still in VNAV path, which is fine. Because as you can see on the FMC CDU, these are the altitudes that we want to be at in the turn. And that's what VNAV path should do for us. Adjust our heading to our current heading as a backup. Let's just have a little look outside. There's the terrain we're talking about. We'll look at the left-hand side. There's a higher terrain to the north. That's why we're circling to the south. And that's why it's important that this training be done in a simulator. First, of course, where crews are qualified and they can appreciate the terrain. So we have one more check to do. That's the landing check, and that won't be completed until we've selected landing flap, which will be somewhere in the short downwind portion beam the runway. Radio altimeter at 1520. Here's our position here. Turning downwind, we'll adjust the heading as a backup. There is a no wind condition. We're 1540 radio altimeter. VSD is looking fine. We'll now configure for landing flap. Today we've selected flaps 30 for a landing flap. There are the points I was mentioning before. We had to create them because we don't have the ability in the simulator to do that. We're still in VNAV path. And we are at flaps 30 and the landing check has been completed. I'm going to pause the simulator here and set up a night scene. So we can better appreciate what we're looking at as we see the runway. It'll be better in this video as a demonstration. Remember, we still have to set the missed approach altitude. We won't do that until we are flying the aircraft manually. We'll set the heading now to the runway course as close as we can. Now, let's have a go outside. Let's have a boo outside here and see what we have. There we are. There's the runway, 2 red and 2 white. So we've succeeded. And at this point, we would disconnect all AFDS, autopilot, auto throttle, disconnect, set the missed approach altitude of flight level 100, and continue on visually. Well, this is what we do at Lat Long Global. If you're interested in hiring us to develop a procedure similar to what you've seen here at Dushanbe, we can do it for any airport in the world. And we'll help you set up your training cycle in the simulator. This procedure is available free for 3 months. Or any airport, any circling to land, for any carrier in the world. We'll actually design it similar to what I have done here today. And we'll give it to you free for use for a 3-month cycle in an offsite database. So you can train your pilots. And when you're satisfied, you will have the maneuver installed in your database of your entire fleet. Thanks for watching. FlatLongGlobal.com. That's what we do. We've been doing it since 1985. Thanks for watching.